Forget Yellowstone. Forget the famous San Andreas fault line cutting through Southern California. Right now, beneath a bustling alpine ski resort in the Sierra Nevada mountains, a sleeping geological titan is beginning to shift. This is the Long Valley Caldera, a massive, sunken volcanic crater 32 kilometers long and 18 kilometers wide. Buried miles below the snow-covered slopes of Mammoth Lakes, California, sits a reservoir of molten rock holding thousands of cubic kilometers of pressure, heat, and toxic gas. For decades, the public believed this region was dormant, a prehistoric relic of a violent Earth long since calmed. But deep subterranean sensors tell a vastly different story. The ground above the magma chamber is inflating, trees are suffocating from toxic gas bubbling up through the soil. Swarms of thousands of micro-earthquakes are fracturing the bedrock beneath the resort town. While millions of people live in the shadow of America's most publicized disaster zones, California's hidden supervolcano is showing clear signs of life. And if this monster ever fully wakes up, it won't just destroy California, it will rewrite the global landscape overnight. To understand the danger hidden beneath Long Valley today, we have to look back 760,000 years into Earth's terrifying past. The event that created the caldera was not a typical volcanic eruption, it was an apocalyptic release of kinetic energy that reshaped the North American continent. At the time, immense tectonic forces pulled the crust of the Great Basin apart, causing molten rock to pool relentlessly beneath the surface. When the overlying crust finally shattered, the pressure release was instantaneous and total. Over 700 cubic kilometers of red-hot magma, toxic gas, and pulverized rock exploded into the atmosphere in a matter of hours. To put that in perspective, the catastrophic 1980 eruption of Mount St. Helens released roughly 1/3 of a cubic kilometer of material. The Long Valley eruption was more than 2,000 times larger. A wall of superheated ash and gas, known as a pyroclastic density current, roared across hundreds of square miles at speeds exceeding 300 miles per hour. This incandescent surge buried the surrounding valleys under hundreds of feet of boiling ash, fusing together into a dense rock layer known today as the Bishop Tuff. The atmosphere above the continent was blanketed with an impenetrable plume of ash that circled the globe. Millions of tons of fine ash settled across nearly half of the contiguous United States, reaching as far east as Kansas and Nebraska. As the underground magma chamber emptied, the roof of the Earth collapsed into the void, leaving behind a gigantic scarred depression in the Earth's crust, the Long Valley Caldera. For hundreds of thousands of years after that apocalyptic blast, Long Valley entered a period of relative quiescence. The giant slept. Tourism flourished, ski lifts were built across Mammoth Mountain, and luxury cabins filled the valleys. But in 1989, the mountain began sending silent, lethal warning signs that geologists could not ignore. Hunters and forest rangers near Horseshoe Lake noticed something unnerving. Acres of healthy pine trees were dying simultaneously. Leaves withered, bark stripped away, and within a few years, over 100 acres of lush forest turned into a ghost-like graveyard of bleached, skeletal trunks. At first, forest managers suspected a severe drought or an outbreak of bark beetles. But when scientists from the United States Geological Survey analyzed the soil, they uncovered a terrifying anomaly. The soil was saturated with lethal concentrations of carbon dioxide, exceeding 30 to 90% of the gas composition in many areas. Normal soil CO2 levels rarely exceed 1%. The gas was so concentrated that it was displacing oxygen in the root zones, literally suffocating the trees from the ground up. In low-lying pockets and snow hollows around Horseshoe Lake, invisible clouds of carbon dioxide began pooling on the ground. Carbon dioxide is odorless, colorless, and heavier than air. Unsuspecting campers and cross-country skiers who rested in these snow depressions experienced sudden dizziness, asphyxiation, and unconsciousness. Several fatal incidents forced authorities to post emergency warning signs around the lake, warning visitors that the very ground beneath their feet was breathing out toxic gas. Where was this gas coming from? Deep beneath Mammoth Mountain, magma was rising into the upper crust. As the molten rock ascended and depressurized, dissolved carbon dioxide gas was released, forcing its way through cracks and faults in the bedrock until it escaped into the atmosphere. The ghost forest was undeniable proof that the supervolcano's plumbing system was active, pressurized, and venting. The toxic gas emissions were only the first chapter of the caldera's modern awakening. In the late 1970s and early 1980s, a series of powerful earthquakes struck the eastern Sierra Nevada region, including 4 magnitude 6 earthquakes in a single 48-hour period in May 1980. These were not typical tectonic plate movements caused by the San Andreas Fault. They were volcanic earthquakes, caused by fluid and magma forcing their way through solid rock. When geologists resurveyed the roads crossing the center of the caldera, they made a shocking discovery. The ground had bulged upward. The center of the caldera floor, an area known as the resurgent dome, had lifted by more than 10 inches in a matter of months. Over the following decades, satellite technology known as interferometric synthetic aperture radar, or INSAR, confirmed that the caldera ground was swelling and deflating like a giant breathing lung. Between 1980 and 2000, the resurgent dome rose by nearly 2 feet. In 2014, the ground began shifting once again. A massive seismic swarm shook the Mammoth Lakes region, recording over 11,000 earthquakes in a single month. Deep underground sensors detected high-frequency tremors known as harmonic tremors, the distinct seismic signature of fluids and molten magma churning through subterranean conduits. Scientists rushed to answer the ultimate question: how much magma is actually down there? For years, some geologists argued that the magma chamber was mostly crystallized and solid, meaning the volcano was incapable of a supereruption. But recent seismic tomography studies published by leading geophysicists revealed a far more ominous reality. Deep beneath the Long Valley caldera sits a colossal magma reservoir containing an estimated 1,000 cubic kilometers of melt. While a significant portion of this chamber is a slush-like mixture of crystals and liquid, the upper sections contain huge reservoirs of liquid, gas-rich rhyolitic magma. The volcano is not dead. It is not even dormant. It is an active magmatic system continuously recharged by heat and molten rock from deep within the Earth's mantle. If the stress on the overlying crust reaches a critical breaking point, what would a modern eruption of the Long Valley caldera actually look like? The nightmare scenario would likely begin with an intense acceleration of seismic activity. Thousands of earthquakes would fracture the roads and infrastructure of Mono County within days. Groundwater temperatures in hot springs would spike to boiling levels as magmatic gases superheat the subterranean aquifers. Phreatomagmatic explosions, steam-driven blasts caused by magma hitting underground water, would shatter the landscape around Mammoth Lakes, sending boulder-sized debris miles into the air. If the main magma chamber breaches the surface, the eruption column would rocket into the stratosphere, reaching altitudes of over 30 miles. Within hours, the skies over California, Nevada, and Utah would turn pitch black as millions of tons of ash block out the sun. The immediate kill zone would extend 50 miles in every direction. Pyroclastic flows, avalanches of glowing ash, shattered pumice, and superheated gases exceeding 1,000 degrees Fahrenheit would race down the eastern slopes of the Sierra Nevada at highway speeds. The town of Mammoth Lakes, local ski resorts, and surrounding highways would be incinerated and buried under hundreds of feet of volcanic rock in minutes. But the localized destruction is only a small fraction of the threat. The true horror of a supervolcano lies in its continental and global impact. Volcanic ash is not soft like wood ash. It consists of microscopic, jagged shards of glass and pulverized rock. As the eruption plume spreads eastward across North America, driven by high-altitude jet streams, ashfall would collapse roofs, short-circuit power grids, and contaminate water reservoirs across the United States. Jet engines traveling over the continent would stall as ingested ash melts inside hot turbines, turning into liquid glass and shutting down commercial aviation nationwide for months. Agriculture in California's Central Valley, the region responsible for producing a major portion of America's fruits, nuts, and vegetables, would be decimated. A layer of toxic volcanic ash just a few inches thick is enough to sterilize topsoil, destroy crops, and poison livestock feed. Furthermore, the massive injection of sulfur dioxide gas into the stratosphere would combine with water vapor to form aerosol mirrors that reflect sunlight back into space. This would trigger a sudden dramatic drop in global temperatures, a phenomenon known as a volcanic winter. Global crop yields would fail, bringing famine, economic collapse, and severe geopolitical instability to nations thousands of miles away from California. Today, the United States Geological Survey keeps the Long Valley caldera under constant 24-hour surveillance. An intricate network of borehole strain meters, tilt meters, GPS receivers, gas sensors, and seismometers monitors every micro-inch of ground movement and every microgram of gas release. Geologists reassure the public that a supereruption is an extremely rare geological event, occurring on timescales of hundreds of thousands of years. They emphasize that smaller, localized eruptions, such as lava dome formations or phreatic steam explosions along the Mono Inyo craters chain, are far more likely in our lifetime than a full-scale superblast. Yet Earth's geological clock does not operate on human schedules. The physical evidence written into the landscape of Eastern California is indisputable. Beneath the scenic mountains, the picturesque alpine lakes, and the bustling ski slopes, an ancient engine of destruction remains active. The Earth is inflating. The soil is breathing poisonous gas. The deep magma chamber is continually recharged. The Long Valley caldera is not a relic of the past. It is a living, breathing giant resting in California's backyard. And as history has proven time and again, when a supervolcano decides to wake up, humanity can do nothing more than watch, evacuate, and endure.